In a hydrogen-oxygen fuel cell, combustion of hydrogen occurs to: first, produce high purity water; second, create potential difference between two electrodes; third, generate heat; fourth, remove adsorbed oxygen from electrode surfaces. First of all, what is fuel cell? Fuel cell is actually a kind of galvanic cell which is designed in such a way so that whatever energy is produced during combustion of fuels like hydrogen, methane will be changed into electrical energy. Now in hydrogen oxygen fuel cell, the fuel is hydrogen and porous carbon electrodes are used. Platinum or palladium is used as catalyst. The electrodes are coated with this platinum or palladium powder which act as catalyst, and the electrolyte used is concentrated aqueous solution of NaOH. The reaction taking place at the cathode: oxygen plus H2O forming OH minus ion. Balancing, this is 2H2O, this is 4OH minus ion. 4 units of negative charge on the product side. OH minus has, each OH minus ion has 1 unit of negative charge. So 4 into OH minus ions means 4 unit of negative charge. So 4 units of negative charge on the product side to balance 4 electrons on the reactant side will be added. So this is the reduction reaction which is taking place. Oxygen has oxidation state of 0. And in OH minus ion, oxidation state of oxygen will be -2. So reduction of oxygen is taking place. And reaction taking place at anode: hydrogen plus OH minus ion forming H2O. Again, to balance the equation, this will be 4H2O and here it will be 2 OH minus ions, and here it will be 4 OH minus ions and 2H2. Now again 4 units of negative charge on the reactant side. To balance the negative charge, 4 electrons will be added on the product side. So this is oxidation reaction. Hydrogen has oxidation state of 0 and in the product water is formed, and in water hydrogen has oxidation state of +1. So this is oxidation reaction. Now during the reaction at the anode, electrons are produced at the anode and these electrons go from anode to cathode in the external circuit, as a result of which current flows in the external circuit in the direction opposite to the direction of flow of electrons, and this flow of electrons also creates a potential difference between two electrodes. So the correct option is: in a hydrogen-oxygen fuel cell, combustion of hydrogen occurs to create potential difference between two electrodes. Option 2 is the correct option. The reaction at the anode, the balanced reaction at the anode is H2 plus 2 OH minus ion forming 2H2O. Now in this case, there are 2 units of negative charge on the reactant side, and to balance the 2 units of negative charge, there will be 2 electrons added on the product side. But the reaction at the cathode, the number of electrons on the reactant side is 4. So in order to add these reduction and oxidation reaction, the number of electrons have to be the same. So multiplying this whole equation by 2, the final equation is 2H2 plus 4OH minus forming 4H2O plus 4 electrons. Now number of electrons gained is equal to number of electrons lost. Adding the reaction at cathode and anode, 4OH minus ion will cancel, 4 electrons and 4 electrons will get cancelled. 4H2O minus 2H2O will be equal to 2H2O. So overall reaction which is taking place is 2H2 plus O2 forming 2H2O. So hydrogen is acting as a fuel which is undergoing combustion. The energy which is produced during this combustion is getting converted into electricity. And this flow of electricity is due to the flow of electrons from anode to cathode in the external circuit.